So good day and welcome to our new video. This time this video would be dedicated to the WildPressure actor. Who are they? You could find the story about them from 2020 on our securelist.com blog post. And let me this time cover the part of the story from 2021, more recent one. They are still mostly detected such malware in the hosts based in Iran, so mostly in one country. Also, in maybe the most interesting for me part from 2021, it's aiming not only Windows operating system, also some of the code are aiming the targets on the macOS operating systems now. It's quite new if you compare with the previous development. And also we were able to find Trojans developed in a Visual Basic script and in a Python. Let us in this video cover step by step all this new VBS Trojan, Python one, and a new C++ development, which is also quite an interesting one because it contains the orchestrator and the plugins, which are orchestrated by the main model. And it's a good example to understand how C++ classes are developed on a level of the structure, the virtual table as a first field, and then all the members of this class. Let us take a look how these objects of the class is constructed by orchestrator and how the VTBL, the table of virtual function, is taken from the plugin. Okay, let us take a look first at the scripts. We would start with the Python part of the malware, because inside this Python part there is a code related to the macOS. So what we have here related to the Python, you see the directory one PyInstaller. PyInstaller is one of the way how to produce Windows PE file from the Python script. So if manufacturers couldn't be sure on a target Windows machine, Python would be installed. They could be sure, I suppose, in case of the Linux, macOS machine, Python would be there. But on the Windows, they need to make a PE out of it, and in this case, PyInstaller is their tool. Could we distinguish the script out of this PyInstaller PE? For sure. Let us firstly check our file with the file utility, our PyInstaller sample. It's a P32 executable. Okay, even with the external PDB, good. But this time I don't want to open in either with PE at once, because you would see all this internal PyInstaller mechanism to exfiltrate all the needed libraries and script out of the archives inside this sample. What I would do, I would use a third-party script, PyInstructor, and you could see here the source of this pretty knowledge. It's just the unarchiver for the PyInstructor, nothing more. Let us use it. So Python PyInstructor and then our sample. Yep, successfully extracted. Okay, now I see here all the files related to our initial archive. Let me take a look. It's quite a number of DLLs, some are Visual C DLLs, some precompiled Python files. I really don't want to take a look at all of them. What I really interested in, it's a Guard file, and also I would need another file with a config for this Guard script. If I would make head and Guard, I would see it's some kind of a Python script. But what I even before we would go inside it, let us open it in our VS Code. PyInstaller, our extracted files, and our Guard. Let us make it as a Python syntaxes parsing. And here I see a lot of usage of the Stack Overflow found third-party code. But besides the code, it's also some custom code from the malefactors. For example, here I see a name of the plist. Plist, to me, looks like not Windows artifacts. Apple.script ZYX plist, etc. Okay, OS type Windows, OS X, even Linux. But to tell you the truth, so far Linux only mentioned in this enumerator, nothing more. So only OS type. But related to the OS X, a lot of code actually. And what I see here, I see the start and the end of the configuration data, GRDS. You remember the script itself is a guard. So GRDS, GRDE, I suppose it's a guard start and guard end. And let me tell you regarding the previous C++ version of this Trojan, the start and end of the configuration data was in the brackets VS32 and VE32. So the same scheme, different X, different signs of starting the config and end, but the same logic. What could we do? We could search in our unarchived information for such marks, right? For the start and end of the configuration data. Why not? Why not? So, for the guard, what I propose to you, I wrote down a simple bash script. It's a first string, it's just extracting of our guard and other files. And second, we are just grabbing for our GRDS and GRDE in our extracted directory. And then with the AWK, we just decoding from the base 62 with actual so far keeping the configuration data in such a format. So let us try and take a look what we would get if we would run get guard config. And in some file inside this unarchived data, we have version of the Trojan 221, then some field which would be sent to the control server during the beaconing, and the most precious part of it, the relays. And you see, the relays here is just a hacked WordPress sites. VP includes, I know these parts, VP content, so it's WordPress, and I'm pretty sure I already checked with domains, it's legit ones, just hacked for the relays. Some PHP scripts which would redirect further the target further on a real control server to hide them a little bit. Okay, so with our first bash script, we take some precious data from the configuration file. What else we have interesting we have in our guard script? I promise you to show some code related not to Windows but to the macOS. Here you see the persistence for Windows, just a very basic one based on the system registry, and also we have plist. And when we decode with data related to plist, you would get the XML which would be dropped to the correspondent user the home directory to auto-run with Trojan when user user on a macOS start his system. You see over there, it's related to persistence on a macOS. What else is interesting here? Oh, for example, here they use launch CTL, also exists only on a macOS, so no such an application under Windows. And the only maybe one more thing I want to show you in this script before we would go to our next Visual Basic script. It's quite a typical way for wait under Windows operating system. So execute silently cmd/c pinging of the local host. Here we go, one script, so two operating system. For one of them, one additional tool like a PyInstaller was used. So you see, this Python script is almost 2000 lines. It's because of many additional tasks like a resolving of the Windows API functions. I saw scripting Trojan or just several hundreds of lines. This one is quite big, and take a look at some self-protection also on board, checking for some security products. And this is the idea. I think you got it. We wouldn't spend much time here. Just most interesting parts are checking for the operating system, implement corresponding persistence, and corresponding way checking for the security solution. So all what we have to do is just to take this Guard file out of the PyInstaller, which we successfully did with a third-party script. Let us now go to the Visual Basic script. And you could ask me, besides these relays, what is this PK parameter? PK is like in the first C++ malware. PK is just the key to communicate with the C2s, just to handle the request only from the Trojans, not from the scanners, not from the researchers, without PK, to distinguish the real infections. So just a key for the communication with the C2. I think enough. Let us take a look at the second script, VBScript. So in our second directory, we have this h6 sample. And if I take a look at it, 6, 5, I see some blob of so far unreadable data and a small decryptor. And if you would take a look at this small code in the very start of this VBS, you would understand it's a self-decryption script with quite a simple function. The logic of the decryption is here, calling h1 with a k 68. H1 function, it's implemented here. It just make a hex byte out of the two ASCII digits, so 00 byte, 2D byte, etc. So just unhexify it, and then XOR with a 68 decimal. Easy. Let me do the decoding with our script. This time I'm able to write it by myself. We need this for the Tandis one, just a small Python decryption. This is effectively unhexify and XORing. Let me run it to get the decrypted part. So you already have the I distinguish with blob. Let me remove the decrypted, removed, and then run get Tandis Python 3 get Tandis py, and now besides the decryption here on the screen, I also again have it in my Visual Basic directory. So I need this decrypted file, and here it goes. This script, you see, this time, in case of Visual Basic, no additional external config files so far. All the configuration data, and I suppose this one is very familiar to you, version 1, 161. We remember 2.2.1 in the case of the Python, and 161 in case of the Visual Basic script. If they are consistent in the version numbers, maybe the Python one is the newest. I don't know if they're consistent. 161 also is applicable to the C++ samples now. Maybe they provide Python after all the others. And with a serial, we observe quite the same string in our Python. And again, hacked WordPress with a relays. Here we go. So one more indicators of network indicators of compromise. And after it, all the logic. And as you could imagine, Visual Basic script, it's Windows only. So all we have to do this time is to provide some basic decryption. I did it with a Python to read all this. For example, the switch of the command, file downloaded, file uploaded, configuration data updated, clean up, then they want to go away. So just all the basic Trojan functionality. And once again, more than 1000 lines. Functionality is quite similar to all the other malware. The funny part of it, they are writing in C++, in Python, and VBS quite similar code, different language, same ideas. They just used XML format to communicate with the C2, they encode it and get the comments from the C2 and all the fingerprinting data and results of the comments on the hosts in XML format as well. And I think it's enough for the VBS part of the story. And besides the decryption of the Trojan itself, it's also one slight encryption inside. It's a hex-to-bin function inside with VBS Trojan, and logic is quite the same. So take two ASCII chars, make a hex representation of byte out of it, and then store it with the key. But the key is different, not 68, but 110. And your script for the decrypting the guard config, Tandis config would be quite the same, just change the constant. Okay, time for the C++ part of the story. Let me remind you previously in our Milum malware, we wrote one more script to get the configuration out of it. Remember, I mentioned with VS32 stuff, start of the configuration data. It's inside the PE this time. In case of the Python guard, it was in a separated file. And here it's only one PE. And when we apply our script to the Milum samples, a lot of the, and some beautification as well, beautification with the JSON tool, the Python model JSON tool, we get the same keys for the communication, relays, and control servers, timeouts, etc. So here you could grab, for example, client ID, grab ID, and so grab some URL, and etc. Make it sort unique. But what about the newer C++ samples? It's just the new detection, the new version of our known Milum malware. And the new development of in the C++ part of the code, it's an first of all orchestrator. Orchestrator is one more PE, native Windows PE, one entry point you see the start entry point. I'm inside the main function. Here it looks for me like some external constructor, because I couldn't imagine the programmer who would name this event enter name here, maybe some constructor for such PEs, and so some operator leave it default event name here. But after all this structured exception handling, synchronization, and getting the name of the config file, in case of different operating system, it would be name would be the same, thumbnail.dat, but directories would be different, right? If the on a newer operating system with a major version above 6, it would be here, and on a previous version it would be there. But my point of interest is a set timer. You see, from my point of view, they are writing in this compiled language a little bit like an interpreted language. Maybe the native language is Python, I don't know. So what happens here? Once in 2 minutes, the timer func would be called. What is inside the timer func? And we, during the such a video, we wouldn't able to analyze all the orchestrator and plugin. I want to lead you a little bit to the part I consider the most interesting one. Here it's parsing of configuration data. You see some plugin startup, some readable strings, and at this function the same trick. They also use some 4 bytes magic, in this case PS, and 2 stars marks around it to mark the configuration data. What is inside? Let me decompile it. Here I see one more parsing. Let me just rename it parser. It's just, believe me, just a parsing of XML, and you wouldn't like to see a video about the parsing XML data and how it happened with all the strings. The more interesting part here, the most fancy part, is happens after this parsing. After parsing, I see some library is loaded, library with this name, and some function with the name access plugin interface is the address of this function, so get it over there in this local variable. And after it, something happened with the structure. Structure is the result of work of this function. Let me, so far I see some kind of structure. I see offsets, offset 4, offset 8. Let me so far call it some plugin object returned by a plugin. And if this function exists in the plugins for this orchestrator, to understand the logic of this object, I have to open the plugin itself, right? So our point of interest in the plugin is access plugin interface. Let us open the corresponding sample, and I see this time it's a dynamic linked library, and besides DLL entry point, access plugin interface is here. And quite a simple function. It's check some flag. If flag is already set, right, nothing would happen. So let me, I don't know the meaning so far, just flag for me. And if it's not set already, it would be set with this logical OR operation. And the result, remember, our object in orchestrator was a result of this access plugin interface function. This is our guy, this is our object, plugin object. And what is it? And now we came to some internals of the C++. You see the readable name, client info interface. And why it's readable to us? Let me just navigate to this table. Here, RTTI, runtime type information, was kept by the developer inside this PE file. That's why we could read this name. And this name, it's mangled. Let me demangle it here. Not only in comics, but in comments by as name. Okay, even more readable. And this is the table of virtual function for the class client info interface. What I propose you to do here, it's make a little renaming with function 1, function 2, and all this table of virtual functions. So effectively the result of our access plugin interface would be the object of a class client info interface, because virtual table VTBL all the time would be the very first field of the object of the class. It's how C++ is built on a level of a binary representation of the class object. Class object is just some kind of a structure as well, but it contains not only data, but also some functions, right? Some members inside it. And the table of the virtual functions, it's a way to point to the precise functions. Okay, so now we know it's a real plugin object, and we could now, in the orchestrator, try to understand all the fields of it. We know the first one. First field is a virtual table, but what about all the other? Plugin option. I see here the offsets. To me, the maximum offset here is 8, no more. And in the function window, I would add not standard enum, but structure plugin, for example. In the plugin structure, if I know the maximum offset is 8, let me create how many fields? 3 fields. So I saw offset 0, effectively it's a virtual table, and 2 more fields. I don't know what is it. I just know it exists because I saw the offsets of it. Struct plugin. After we created this simple structure, we could here make a plugin option, not int. We know it's not an integer, it's an object. We saw the return from our plugin. Return was the pointer to object. Let us implement it here. Convert to pointer to structure. Our struct plugin. Apply it. And you see, applying, we also see some first string allocation, the bytes for the first string. Let me name it string 1. Here the same for the string 2, some allocation of the bytes for the white string, string 2. And the most interesting part, after the allocation and copying, here it's a sum calling, right? It takes our virtual table, takes the offset 4, call it with the argument of plugin option. Take a look at the profile. With call, it's a way how the function in the C++ would be called. The very first argument would be the object of this class. Here we go, struct plugin, our pointer to the object of our class. So this orchestrator creates the object and call some function in our virtual table, or the table of virtual functions of our plugin option. It looks to me like we need another small structure, right? Let us create it here. With time, it would be plugin virtual table, and how many functions we want to add here. Do you remember in the plugin itself, these pointers, also 3 of them, right? Yes, 2 of them are similar, but I also need 3 fields for this one, and this one. I would do so. First one, second one, and third. Let it name it function 1, function 2, and the third one. And after it, it would become obvious what would be the offset for. It's calling of the second function. So they hard code in the orchestrator the calling of second function in the plugin virtual table. All we have to do now, we just have to set the type of our virtual table, right? It would be the pointer to our VTBL. Agree? The pointer here and offset 4 would be function 2. So, and now our Miss Ida resolved for us second function in virtual table, and we are on the safe side to make the function 2 like the function with 1 argument object of the class. And the continuation of our analysis would be in a plugin, right? So we create so far in orchestrator 2 structures for the class object and for the virtual table. And due to this, we understand what would be called by the orchestrator. Function 2 in our plugin over there. Function 2 is here. Please decompile. And I would set double pointer to some white char. It's a pointer to our plugin option. Do I have to recreate plugin option here? I prefer to import it from my orchestrator. So from the local types, I would choose struct plugin, and struct plugin VT would export to header file. Yes, please include dependencies. Export. 2 types have been exported. Okay. And now I would import it in my another sample. What for? To show to my function 2 of client info interface the type of the data. So file, bloat file, and parse header file. And in orchestrator, just exported this one. Compilation successful. Good to know. Now I need to convert to pointer to structure. Struct plugin. Agree? Done. This becomes it's after naming. I'm not fully happy with it. Let it be plugin option of struct plugin. Let me take a look. And now you could see all the calling of the function. So yes, you're on the safe side to also make the third function the same prototype, 1 pointer to struct plugin. What we just effectively do, we export description for the virtual table and for the class object and import it to our plugin. And by the way, in this case, we were able to get the 3 plugins, and you don't have to make the same exercise with a Shift F9, insert, and create 2 small structures. Just use the 1 header file. And by the way, the same trick for the exporting data. If you have the cluster of similar samples, we cover it in our X training, in our videos, also how to do it for the bigger structures, standard structures related to the sums, BMP files, steganography. You would method in the X training as well. And maybe the last thing here I want to show you, it's one ability of our own plugin. So far in these structures, I just said, so far I used only the abilities of IDA, nothing more, right? Creating with 2. But in our plugin, I could also choose structure add virtual table, and I could give the address of virtual table for us for the better navigation in our sample. Now I take the RVA of the VF table, and after read on structures here, I want to add it, and this address would go there. Done. With virtual table, not just the pointer to our structure, but as well the contains the real address or RVA of the functions in our PE. And now, after it, you could also navigate like this. Addresses is over there, so navigation to the function 2 becomes easier. So what we have done now with the C++, if you would return to the orchestrator, you would see the meaning of the two or more fields in our structure. It would be the destination, plugin destination, and the function name. So some data to communicate between the plugin and orchestrator to understand what have to be run, where all the gathered data have to be dropped, or something like this. And what I really wanted to show here is how the object of the class are built inside the very special first field, and how you could create it by your own. I think this is the most interesting part in this C++ new samples of the WildPressure, the protocol of the communicating between the models. I don't think it's a perfect one, because imagine if the developer decide to change the structure of this object, they would need to change it on both sides, right? Because the orchestrator just rely on the structure of this object heavily. The orchestrator is creating the object of this class, right? And only VTBL comes from the plugin. So this is it. Import, export, and the structure of the class. And I think now we are ready to wrap up all what we have to found in the samples of WildPressure 2021. And in the end, let me emphasize the most interesting part, at least for me, from these samples from the WildPressure. The Visual Basic script just was interesting because it was the first what we found this time, and it was our assumption about the several programming language was right. So we remember some field with communication with the C2. It was written C++ is the language of this Trojan. Why to mention it? If you develop control server and Trojan, why to let the control server know the language of the Trojan? Well, maybe Trojans in other languages also exist. Why? Maybe because they want to avoid detections on the different hosts. On some hosts and some security products could detect the C++ version, but couldn't detect, for example, VBS. On another host, picture is opposite. So I think main reason to develop different version, it's anti-detection. So it was VBS just was our proof of our theory about the different languages of this Trojan. But with just self-decrypting, we are decrypted with a simple Python script. After it, we take our Guard Python script from the PyInstaller, and here for sure the most interesting part for me, it is a code related to the macOS. So among the targets, somebody used this operating system, not only Windows. Interesting. And also even Linux is mentioned over there. Remember the enumerator, no code related to Linux so far, by the way, but it was in the numerator. Maybe we could await later some Linux malware from them. And in C++, it was the most interesting part was the communication protocol between the orchestrator and the Trojan, now we could enjoy all this RTTI data. RTTI is a great help for the researcher, right? You see the name of the class. Oh, cool, cool. By the way, no name of the function this time, right? Only the class. And now you know how the object of the class are built inside. So we use with a simple protocol between orchestrator and plugins to show the classes object and the analysis over C++ code. This is it. For the additional technical details, please visit securelist.com for sure. With 40 minutes video, it's not enough to cover all. And also on the TIP, we have a full technical report. And hope to see you next time. We will try to choose some interesting type of the malware, maybe written in Go, something like this. And see you. Bye-bye.